left off, the middle ordinate example, and went through everything here, and we ended up finding out that our middle ordinate is 13 feet. But actually, I want to make this one correction here before we move on. It's actually 13.75 feet, if I remember correctly. So you can go ahead and make that correction. Okay, next problem. So in this example, we have a few things going on here. What is given is your R min, okay? Your minimum radius is given, and it's given at 1,500 feet. This is a 4-lane road with a maximum super elevation of 7% and a side friction coefficient of 0.2. So it's a 4-lane road, and this is the center line here. So what I want to go ahead and do is draw what's actually going on here. All right. So there you have it. You have 2 lanes traveling in this direction. Okay. And then you have 2 lanes traveling in that direction. And of course, your center line is right there. And that's what's been measured. So what do we want to find? Well, you want to find how close can an object be placed near the roadway edge and not obstruct any sight lines. Basically, you just want to find the middle ordinate. And remember, really what we're looking for is that there, the middle ordinate. Okay, so the middle ordinate is, go ahead and write that equation down again. The middle ordinate is equal to R sub I times 1 minus your cosine of 28.65 times stopping sight distance, all of that divided by your R sub I. Alright, and remember, this is important because this middle ordinate is with respect to a certain stopping sight distance. Therefore, it's with respect to a certain speed. Now, a speed wasn't given to you here, but you do have the information here that you can use to figure out what that speed is. So let's go ahead and continue on with that. Alright, well, what we know here is that R is equal to, or R min is equal to our speed divided by 15 times the super elevation times the coefficient of friction. This would be good practice for the test because there's different ways you can ask questions like this. Alright, now that is also equal to 1,500 u squared over 15 times 0.07. Remember, that needs to be a decimal. If it's not a decimal, it's not right. Plus 0.2. So right then and there, you can figure out what your speed, at least you can estimate what your speed is, knowing what your R min is, which was given to you. Okay? So from that, we can figure out that our speed is equal to the square root of all of these terms. That's 1,500 times your 15 times the 0.07 plus 0.2. Okay, you end up finding out that our speed is equal to just about 77.9. Okay, now from there, I have my speed, which means I can figure out what my stopping sight distance is. And if I can figure out what my stopping sight distance is, I'm that much closer to figuring out what my minimum radius is. So, continuing on here, let's go ahead and try and figure out what our stopping sight distance. Now, I didn't give you any information about the grade, so assuming the road is level, the stopping sight distance will be as follows. 77.9 times 1.47 times 2.5, which is what we go ahead and assume for design. Then we have our braking distance, which is 77.9 squared, divided by 30 times 0.348. That should give me a stopping sight distance equal to 867.8, in which case we are going to round that up to 870. Okay. Alright, so far so good. Now that I have my stopping sight distance, I can use that and plug that in there. The only other thing that's left to basically figure out is what my radius should be, the radius that I should be using. So if I reference this RMN right here, okay, what I notice is that the R that I should be using is with respect to the inside lane. Okay, so the middle of the inside lane, that's the R that I want. So we have our R sub I is equal to, okay, it is equal to my R min, which is also our R from the center line, okay, minus what? Well, if we look up here, we see that this is where my R min is. I need to subtract 12 and a 6 here. So minus 12 minus 6, and I end up getting that my R sub I is equal to 1482 feet. Well, from this point on, it's just nothing but just plugging and chugging. So let's just go ahead and do that. We got our M sub I is equal to 1482 times 1 minus the cosine, 28.65. You got your stopping sight distance, which is 870 feet. All of that divided by 1482. And now I figured out that my N sub I is equal to 63.4 feet. Okay, 63.4 feet. Now, if you kind of refer back to the question, that doesn't really answer what was being asked. See, it says, how close can an object be placed near the roadway edge? Okay. What we actually found was the M sub I, which was measured from here, okay, all the way down. And what I'm looking for is how far the distance should be from here. So what that means is that I just need to get the answer, I need to subtract 63.4 minus, what's that, 6 feet. Okay. And in doing so, I end up getting 57.4 feet. And that is my answer. 57.4 feet from the edge of the road.